Let's take a quick look at the two tests that I've written for this. One is a Solidity piece of code that goes in the test directory. So you do truffle init, and that gives you a set of directories. You put your contract in the contracts directory. The file name has to be the same as the contract. And then in the test directory, whatever Solidity files you have and JavaScript files, it will run those when you do a truffle test. So the first one is just a test for this new pay contract. So I import it, and then I create an instance of the contract. And at this point, the constructor has been run, but nothing else. So the question that I can test, what can I evaluate about this contract? Well, the first thing would be that there are no payments yet. So I've got this test function that is going to run. It'll run each thing inside the contract that has a test as the beginning of the name. And I can find out how many payments do I have after the constructor. And the answer is I should have this assert compares to 0. You could do this with an if in here and just raise an error if it doesn't match, but I've done it with an assert that there are 0 for the number of payments that have occurred, and if I don't get that, I get the error message, no payments yet. So I can test that we haven't had any payments yet. That'd be a starting point. And I can also get the balance for the contract, which is I can find out what's the value in Ethereum of the payments. And again, I do a little test that sees that I haven't had any payments yet. I could build other tests at this point, but this is enough to at least get me off the ground with a Solidity contract. It compiles, it builds, the constructor runs, and my initial values are correct. Usually I would have other tests at this point that look at other calls into the contract. But realistically, what I want to do is I want to step up a level from what's in the Solidity land, and I want to be able to run stuff at the interface land of the contract. So again, I'm going to do a test. You can look up about what the capabilities for using Mocha as testing, but that's the one that's built into Truffle. And I do this artifacts require. And this brings in the contract and makes so I can call it. And then I have a contract pt4 function that I'm going to test. I have access to the accounts that are listed in when you run Truffle develop, and that starts with 0 and goes to 9. I just picked the first account. It has funds, and I await for the pt4 to actually run. So async here, this is the latest version of JavaScript, but async is going to call this, wait for the contract to construct, and again, I do the pt4 contract and I wait for the constructor to complete. If there were parameters to the constructor, they would go right there. But when I get done, I've got this variable pt4 item that is the way that I'm going to access the payment contract. And this is supposed to be English. I really despise that, but hey, that's the way Mocha works. Is for some reason they think that English makes sense as a language. I don't think it does, but it kind of reads like English. It should pay for an item. And again, there's an async right there, which means I'm going to wait for something to run, and it creates a function that says received funds, and I call the received funds function. Then I turn around and I wait for it to pay, and I pay 42 from account 2, which is this guy up here. It's the second account, and I send a value of 1,000. And then I'm waiting again for the received funds, and I do a get on that received funds, which is the array, and I do an assertion that the result event, which I'm after the event, is received funds, and that we actually get an event and that it should occur. Then I look at the number of payments. I'm expecting one payment, and I await for the paid items to equal 1,000, that this person has actually paid 1,000. So this is the kind of a thing that you build a test for, that the contract actually ran and did something. And realistically, the JavaScript is much more powerful for testing than the Solidity, but almost every contract I will have some amount of Solidity tests, probably fairly simple, that verify it got built, it got loaded, and it runs, Truffle test runs all the Solidity first stuff, so If for some reason your contract isn't loading, or the contract didn't compile, or something is wrong with the constructor, the Solidity tests catch that level. Then I do tests that can actually look at calling it, the events, the results, and this makes a fairly straightforward kind of a test for events. When I get my tests done, I do truffle test. It goes and runs it. You get some output that looks prettier than this because it's in color. You get the amount of time that it took to run it. You find out what got compiled. Okay? And hopefully you get something at the bottom that says that you're passing the set of tests. But you need to build for the homework a set of tests that work something like this. It's probably not as comprehensive, but that hashes a document, takes the hash code for a document, registers it on the chain, and gives you back, yeah, I got this set of results. Okay, one last announcement for this week. Okay, and I hopefully, if the gods of uploading and internet are working well for me, I will get this actually uploaded before the beginning of our class. But as quick as this can be uploaded, this Friday we have a guest speaker coming in from England. He's not coming in, he's coming in via YouTube. But we are going to start looking at a different system called Marlowe that works in a fundamentally different way. I am learning it right now, so I'm only a little bit ahead of you, but I'm getting lots of help to learn it. And he is building videos, and there is a tutorial for this. So we're going to look at software contracts on a slightly different system, financial contracts. But we're going to work through some base level of exercises in what is right now at the forefront of research in verification and blockchain contracts. But they're, unlike Solidity, that would be very, very difficult to verify, these were actually built for automated verification. So I'm spectacularly excited about this. I don't know if you are. This guy is actually the author of the Marlowe system, and he works for IOHK doing research. And IOHK stuff is written in Haskell. I know some of you don't know Haskell, or you probably either love it or despise it. But Marlowe sits on top of Haskell and is its own language. So although you'll see a little bit of Haskell showing through, mostly it's a domain-specific language for financial contracts. Now, unlike other languages, this thing works really, really differently than you might be familiar with. So I'm going to, his stuff is really well done and well presented, but I'm also working through my set of notes on this is what it took me to get to build a contract. And you're going to get both the I don't know it and I'm figuring it out side of it, as well as the expert who understands it and is presenting it as this is how it works. And hopefully we'll have some of both. That's coming up starting this Friday. I would prompt everyone to ask as many questions. At the end of the stuff on Marlowe, which will probably be close to the end of the semester, we're actually going to be asking you to evaluate how Marlowe worked and what you learned. So one of your homework exercises from this is to give us feedback on the Marlowe system itself and tell us, what happened and what did you have difficulty with, what was hard to understand, what made sense, how did it work for you? And that part about how it works for you is how we're going to improve the Marlowe system and make it into a better system to work with people. In terms of languages and language processing, this is as different approach to languages as anything I have ever seen. So, as a research thing, this is a domain-specific language, and it is truly unique. So if you're struggling with it, ask lots of questions. I spent the whole weekend beating my head against it and learning it and actually getting the simplest things to work. But I got something to work, and I'm truly looking forward to joining you in the learning process, and hopefully I can stay ahead of the rest of you and run into the walls faster and harder and poke holes in them for you. But that is my hope and my expectation for this. So that's coming up this Friday, and I'm very, very excited.